Hi, Kevin. Thank you for being with us today.
Federico, I'm pleased to be here.
Well, I will start with a very simple question, and is just asking you if you can tell us something about yourself.
Okay. Kevin Mackey, I'm native Irish from Dublin. Lived in Spain, lived in France, and for nearly 30 years, I am now living in the United States. 20 some in the San Francisco Bay Area, where I was fortunate to work at places like Intel, eBay, Realtor.com, Microsoft, actually, their Silicon Valley campus. As a consultant, most of the time, in fact, I was consulting to Microsoft's internal IT. I've been fortunate to work with sort of large technology companies, and then almost 10 years ago, I moved to Kansas City in Missouri. Sort of a boy who grew up on an island and then moved to the edge of the Pacific Ocean, now lives very close to the geographical center of the US. Apparently, I needed a change. And I've continued consulting here, large because I don't like working for, I don't like working for companies anymore. Because as a consultant, you get different challenges, and apparently I get bored easily. So longest I ever worked was for Digital Equipment Corporation, which also tells you maybe, okay, this guy is old, that company is long gone. So I worked for them for 12 years, and largely I've been consulting ever since.
Well, I'm very happy to have an Irish guest because I used to live in Ireland and I really enjoyed my time there. Everyone was really wonderful with me, so always happy to connect with someone from Dublin. We have seen that you have a lot of very interesting experiences, and today we are interested in focusing in particular on migration. So can you tell us a bit more about your specific experience with migrations?
Yeah, there've been a variety of them. Helped migrate one company a couple of years ago, just as the pandemic hit, from an Oracle OBIE environment over to, they were going full SQL Server and Power BI and cubes and so on. So, as I hate to do the same thing more than twice at least, I started generating the code that would build the cubes for them and help build their ETL process. And that was a relatively straightforward, okay, they had these reports, they need them in Power BI. They had a Power BI expert, so long as the data could be provided. So that the much larger one, which has taken, that one took months to do. The larger one, which is a mainframe modernization, is taking years because, for a variety of reasons, there's over 30 years of code. There's that plus however many more of data. So the company, in the transportation logistics area, have had and still have a mainframe application running on top of ZOS. However, on top of that, they have, it's a programming language come database management, database management environment. and file-based, as it turns out. So they made an interesting choice not to do, okay, let's do greenfield, let's rewrite everything in Java and turn the mainframe off one day, turn the Java on, and everything would be just fine. And that was partly because they no longer had the requirements, the business rules. Business rules were built into the code at this point. The people who had written, you know, some at least had moved on to other companies, others presumably had moved on to the great hereafter. A number of people certainly had retired, so they had an enormous amount of code, an enormous amount of business data, and they decided, okay, let's migrate slowly. They contracted with a company in New York that would convert their programming code into Java, and decided to do this on a sort of application area by application area at a time. However, that required that the new applications as they came online would have the data, all of the data that they might need to cope with it. So they needed to move the data as well. And both systems had to be in sync. So the approach they took was they had someone who actually worked for the company that produced this database environment plus programming language, so knew the internals quite well. And what they did was they wrote a program augmenter, I suppose is the best you can say, that searched for insert statements or create statements, update statements, delete statements, and wrapped them in what they called an XML enabler. Happily, the programming language had a save as XML. So it would take the current record that it was operating on, and as it committed it, it would render that record in XML and drop it into MQ series message queuing.
Oh, smart.
Said, we need someone the other end of this to catch this and persist it, please. Without the please. Just, which, if we were doing it today, we might have used Kafka or something like that. And we might, who don't know, persist it in the cloud, whatever. They went, invested in a set of SQL Server boxes, and looking at it initially, thought was, Microsoft has this BizTalk thing for electronic data interchange, and it knows about XML. However, the company, to mount a BizTalk cluster of the size they were going to need, the company didn't have the expertise in that. I had worked with BizTalk within the Microsoft internal IT department for their own EDI purposes. So, you know, we looked at that and went, perhaps not. Plus, there was the requirement that within 3 seconds of the record being persisted on the mainframe, it needed to be persisted in the SQL Server. Or else the new programs that were coming online would comfortably get out of step, uncomfortably get out of step. So that was a hard requirement. And I wasn't sure that we could build a BizTalk cluster large enough because there were over 200 files on the mainframe that were being written for customers, for shipping, for quotes, and so on. And one of the features and one of the reasons the company chose this mainframe application is there was almost no persistence penalty.
Mm-hmm.
As far as the program was concerned, it committed a record. Now, as it turns out, it committed it to memory, and the underlying software then ensured that it was journaled and persisted to disk well enough that even if everything crashed, and mainframes don't often do that, but even if everything crashed, you still had your data up to maybe a second or two ago, which caused some interesting patterns in how the people wrote records. They'd write a basic structure, and then as the program found the next bit of data to go into that record, would write it again, would write it again, would write it again, and slowly over time, over 5 minutes or whatever, build the record. Each of those commits caused XML enablement to say, we have a message, send it. So we were getting records for the same record, messages for the same record that were milliseconds apart, like ones of milliseconds, not tens or 100s, or ones. So I thought, perhaps BizTalk, I don't know, may or may not be able to take it, but let's see. So SQL Server has a queuing system built in service broker, sorry. And okay, that was totally within the database. Automatically, if you have a queue, it will automatically invoke a stored procedure to dequeue messages and persist them. So, okay, let's go this way. And it had the virtue that most queuing systems have. It was relatively bulletproof. The idea was we could not lose messages. Hence MQ series on the mainframe and service broker on the SQL Server environment. So then it was just a question of writing several hundred stored procedures that knew how to shred XML messages and persist them into tables that looked awfully like the file structures. And of course, on mainframe or file-based systems, they've got different record types. Therefore, this record type has 15 fields, this record type has 115 fields, and so on. So we had to present the data in SQL Server, which doesn't, or in relational databases, which don't really like repeating groups on different record structures within the one table. So we had to shatter 200 and some files, became 460 some tables, and so on. A great deal of code needed to be written. And while it was fun doing the first one and the second one and the 10th one, I think it was, after a while, the patterns became the same. DQ a message or DQ a batch of messages, sort them by some time that was within the message, shred the XML, persist it, update the record if it's there, create a new record if it's not. If there are recurring fields, which many had, write them into a child table. And in the case of, we deleted it, well, mark it for deletion. Don't get rid of it yet. Mark it for deletion, because the program at the other end, the Java program, needs to know that what used to be there is no longer. So that's when I decided that we needed to look at maybe code generation. The only thing that's changing are the structure of the message, what fields are there, and how many. Some of the files had, as I said, 15 fields. There's one that has 400 and some. So
too many.
Exactly too many, but it's the way the data was. Therefore, we had to make the data the way the data was. So that's when we decided, let's do some code generation. So we built an entire environment around that, metadata that held all of the information about the tables, table names, what the different record types were. Did this file have recurring fields? Okay, then we have a reoccurs table, and what columns go in there. And once we had that information, we could then generate the stored procedures, which are in service broker called activation stored procedures. A message arrives, SQL Server activates the stored procedure to go do something. We then used the same metadata because shredding XML in SQL is a terrible idea. It's capable of doing it, but there are many path statements, and it's just, we were running out of compute power and temporary temp DB space. So we changed that into C#. So we generate the C# code to shred the message, because again, it's search for this element, search for this element, this element, this element. And the only difference between the 200 and something C# programs is which elements are we searching for. Always record key, always date timestamp, and then whatever else is in the message.
I think you raise 2 points that I think are very important for, maybe I want to stress them for people that have not experienced with migration. The first one is that you have to handle these projects, this large migration step by step, so migrating one piece at a time. And the other one is that you don't just migrate the code, but there is also the data. And because of the interaction between these 2 points, the fact that you do things in step and you migrate both code and data, there is this maybe interim phase in which you have to keep in sync data in 2 different places, and that can be very challenging, and maybe one could underestimate these challenges before starting the project.
Very definitely. It was, once some parts of the project were up and running, it was discovered that, oh, and if we persist new data in the SQL Server environment, we may have to route that back to the mainframe so that the programs that are in another application area but still touching the same kind of code will know about that. So yeah, that became clear possibly a year into the process. The first part of it was, okay, can we get the data over and ensure that it can occur as the first Java programs began to come online? And then it was kind of, okay, we need the second half, which is now this is a circle or a cycle. It's an ecosystem, which is a word I've tried to persuade these people. You have to think of your data as now in an ecosystem. It lives in more than one place. Over here, we have the system of record for programs that are not yet migrated. Here now is the system of record for programs that have been migrated. And both the systems that are not of record for that particular piece of data need to know about this data. And we had to build quite a large thing. Mercifully, we did not have to worry about the routing the data back. The people who did the initial XML enablement, there were capabilities within that mainframe environment, so the Java programs could effectively post the message back, and the HTTP environment picked it up and persisted it. And they subsequently set flags and they said, okay, don't route this back because this is the system record, and therefore. So then we had to modify our code templates to say, okay, if you get a message that shouldn't be routed further to the system of record, skip it. Yeah, don't do that.
Maybe one question that I would like to ask is this. It's obvious from the discussion up to this point that doing migration is not it's not easy. It's not a fun project that you do in 1 week. So one may wonder, why should someone migrate a system that is working to another platform?
There were several reasons. One I alluded to earlier, 30 and more years of code and the environment in which that code was written is old. It is not particularly modern. And the company that supplied that particular database, common language, and so on, is de-emphasizing that as they move forward. So, okay, many new things are not going to be coming there. Two, their programmers were retiring or had retired. And you go out on DICE, Indeed, or whatever, and say, hey, I'm looking for programmers for this prehistoric piece of technology, and it's silence, not a great deal of interest. Or if you do find someone, they would be phenomenally expensive because, hey, sorry, demand, so there was that. Finding new people or moving their application to some, adding new 21st century capabilities, much harder to do in the environment they were in. Finding people to do it, difficult. And IBM mainframes are very expensive. The new environment, SQL Server Enterprise Edition on some of the large scale boxes they have, they're not cheap either, without any question. The Docker-based application servers they're using for their Java programs, you buy them in bunches from, a pallet of them for 2.5 months rent on the mainframe. So it's a less expensive environment. I was going to say cheaper, but it's a less expensive environment to which they're moving. So those are some of the reasons. Expense, greater facility to add newer features. They could make this cloud-based without a whole lot of difficulty. Just move the containers up to Azure or AWS. IBM's been buying cloud companies, but doesn't really have the most coordinated cloud environment right now, and the code that they currently have not truly cloud capable. So they could move there with greater facility. And if a company wants to get rid of their on-premises hardware and so on, harder to do if your on-premises hardware fills a room and it's one box. Slight exaggeration, it doesn't quite fill the room, but still, it is big iron and there's no question of that. So expense, ease of moving to a more modern environment, and the fact that you may or may not be able to find people who can do the work that has been going on for decades. So these are reasons, but yes, it is never easy. Sometimes it's actually possible. We both have been in environments where, that didn't work. It's not easy. It's not inexpensive. But the goal, hopefully, is to enable the company be more, I don't want to use this term, agile. And I don't mean in the software development environment, simply more agile in their marketplace. And they'll have systems that will benefit where they want to be rather than where they've come from.
And, it's probably not cheap to do this migration, but on the other hand, they are probably migrating systems that are very valuable to them and that have been very valuable for many years. Otherwise, they wouldn't be legacy.
Exactly. Yes. A number of financial institutions around this area are doing the same thing. I mean, financial institutions have lived in mainframes for a long time because they work. The systems are powerful. The systems are important and beneficial to the company. But sometimes then the company's business model becomes constricted by legacy.
I think one question that someone approaching this field could ask is if one has to migrate a system from, let's say, RPG, COBOL, or maybe some 4GL that was briefly used some tens of years ago, to a modern language, I guess there are two possible ways to do that. One would be just looking at the old code and rewriting from scratch in Java, C#, Python, or instead writing a transpiler or use some other tools that automatically does the translation. And so what do you think about these two options?
For option number one, I think you need an army, or you may. I don't know if it's known how many billions of lines of COBOL exist out there. COBOL, the only programming language where the programmers would get writer's cramp typing it. There was so much. The problem with looking at the old code and, okay, now write the new one, the new code, is that's people intensive, which, may not be a huge problem. You basically hire the entire class of the next CS group out of college, and you say, okay, here's the fundamentals of what RPG looks like and what an input spec looks like, a calculation spec. I used to teach RPG, and an output spec looks like, Java, C#, Python, whatever. Go, yeah. Make the translation. So the people part of it is possible to get over. The difficulty I personally feel with that is you then wind up with what I call artisanal code, which is great if you're making pottery. No two pots look the same. But that's the charm, and that's it's handcrafted. You lack the consistency that your code's going to need, because one person with the best will in the world doing the same thing several times will accidentally, across a week, across a month, differences creep in, even if you've got templates and so on. 10 people doing the same thing with templates all laid out and so on. Do this, do not deviate, we fire you. You will, at the end of a month, and 10 people doing 10 things, you will wind up with at least 40 variations. I'm going 60-40, and that's probably low. There'll be variations, because we are not very good at doing the same thing time and time and time again without deviation. Now, sometimes it's good to, The 10th might be better than the first 4. However, across 10 people, you'll have 4 things that are at the 10th level that are better, but they're not the same. And then when bugs crop up, as sadly they do, it's a major exercise to find out, okay, what's different here as opposed to there. So the idea, and this is part of the reason we went for generating the code that we were producing to shred messages and persist and so on, is once we had a pattern, then do it 220 times, just varying what are the columns. In the case of the original code to Java, again, the approach was a third-party company that had something in this area. They had to build themselves a grammar or something. I don't know. I know nothing of the internals of it. But again, the idea was that we need to stamp this code out, and it all looks the same. The virtue in it is that it is either all wrong, in which case you fix the transpiler, the template, whatever assumption you made that was wrong, you fix it, and then they're all right. And it may not be the world's finest code, but code file number 1 and code file number 257 follow the same pattern religiously, because computers know how to do that. So the preference would be, and it's certainly not easy, but the preference would be get a computer to do this, or as much of this as is possible.
And very happy you said as much of this as possible, because this was exactly the question that I wanted to ask next. That is, how much code do you think can be actually translated? Because I think this is a typical question that someone has. There are maybe people that have unrealistic expectations, like, okay, I click a button and 100% of my code will be perfectly translated and extremely readable. And
Excuse me.
So can you tell us, in your opinion, how much code can be typically translated when doing a migration?
Personally, I think a good target to aim for is in and around the 70-something%. Would hope there. 80-20 is a nice number, but I haven't gotten there yet. Now that may be because as part of this exercise, as we've discussed earlier, I had to write 2 different transpilers. And it could be the weakness of the transpiler creator that 80% was not reachable. Nice goal. 70-75% should be the target. You could say 100% should be the target, but it actually isn't. I don't believe it's possible. I cannot say that it's not possible, because there are people far cleverer than I out there, and people who actually write compilers for a living, know how to take code in one form and produce perfectly working code in another form. Just really what compilers do. So there are people who are capable of this. For the rest of us, then you need enough that it's worth to invest the effort and time to write the transpiler in the first place, because you could sit down and start rewriting the code and you'll get immediate results, and some of them may actually be useful, but you will get immediate results. If you decide to go the transpiler route, then you won't get immediate results. There's this whole period where you have to figure out what the patterns in the language are if you don't happen to have a grammar for it or one available out on GitHub. You then have to figure out what the patterns of the output are supposed to look like. And this is not a small task. A period of time will go by, and it's not a day or two, before you begin to get results. So you have to aim for enough that will give you a decent return on that upfront investment where you are getting nothing at all except frustration.
I think this is a very good point, and one should remember that we are not writing transpiler for fun, or not only for fun. For sure, the client is not paying it for the fun. Sake of reaching some theoretical goal of 100% translation at some point. It just makes sense to translate what will be very hard to translate automatically. It makes sense to translate it manually, that part that hopefully is small enough to be tractable by a smaller army that if you had to translate.
Yes, yeah. And if nothing else, by then you will have better patterns to explain to your smaller army, because you've had to build them into your transpiler. Part of this migration project, the company that was translating the Java was doing the online work on screens and so on. However, this is a mainframe, batch processing. They were converting the batch programs as well. However, again, we are faced with data. So just to provide the background, the batch programs operated basically on extract files of data. The development environment that the company has had they call them fun loads, which is a fast unload language. And so they had written this to sort of pull data out of different files, dump them into a fixed length format, very like an RPG output spec. In column 3 for 12 spaces, in column 15, and so on. The problem is they had hundreds of these fast unload programs, which worked terribly well, but now their data is in SQL environment. So they needed the fun load script in SQL, and they wrote themselves a generic SQL executor, effectively. So, okay, call this script, dump the file out, and then the transpiled or the converted Java batch program will then go operate on it. And they said, Kevin, we have several hundred. It was 700 the last time I checked of these scripts. Can you and the rest of the people with whom you work convert these? And I said, you know what I'm going to do? I'm not going to write these by hand, because no. So let's go take a look at what that might look like.
We are seeing the slide and a test file.
Yeah, this is in fact what that fast unload code looks like. So a job, a step. This is the file to be opened. Some things to figure out what today is. Work out basically the last week, effectively. Subtract 7 days ago to now. And then quite procedural for each record within the file. Check this column. If it's this value, then go do this, otherwise skip the record. And if these conditions are met, basically if the date is within the 2 dates we calculated, and this set of conditions are true, and if this exists and this other column exists, which effectively translates into SQL is null, not null, then put, which is basically the output value, put in column 9 for string 11 the value in that column and this other one, because these are the ones we checked. If they actually exist, then dump the values out. End if, end if, end if, otherwise skip, end select, end for. Basically, all right, run through the code and or run through the file. When these conditions are met, dump the values out. Please, Kevin, translate this to SQL. So I have that code, which is in fact in a file called test funload.txt. And here Kevin goes, hits enter, and it all blows up. I don't know.
Parsing went well. This is reassuring.
Okay. Generating the SQL file, getting the column list, because of course the SQL in the in the file itself on the mainframe, dot is used as a separator for the pieces of the column name. In SQL, we changed it to underscores. So, okay. What are the columns we're needing? So we have the metadata for all of bus audit available somewhere. It's the same metadata we use to generate the XML shredding and persisting and so on. So it was fortunate I was able to reuse the data. And where did I put SQL? Oh, yes. A blank page, but it was open to a particular file and says, this has just been changed. Yes.
Nice.
10:22, which I'm not sure what time it is where you are, so 7 hours. So
yes, 7.
22 minutes past 5 in the evening, 17:22. So, hey, Kevin's being honest, it was produced just now. This is the name of the output file because that's what they wanted, which is basically MCC is the name for their new application environment. The name of the job, the step.sql, the name of the job, the step.sql. And these are hopefully all the conditions correctly in place. You know, go figure out what the dates are and then put it all out in one fixed position record. And interestingly enough, because this starts at position 9, then don't forget to dump out 8 spaces first.
Good point.
Because literally it has an output record and it's putting data in at certain positions, but SQL has no concept of an output record. So, okay, pad this as much as you need to know. By the way, if they're null, just make sure, and so on. So this, yes, it took time to write this transpiler, and you need to produce something that can recoup that. In testing, this translates, and that was the number, that's the set I had. 237 of these funload scripts can be converted in 3 minutes. Because, you know, there's only one in here, but I could have made several, and it'll make one SQL file for each of these. Basically, it's an Antler parser that produces everything, and the job is the owner of everything below it, and therefore the transpiler iterates across the tree looking for job statements and says, okay, I have a job statement. Go do that. Now move to the next job statement. Go do that, and so on. And to do that, I had to basically write the grammar for that. So the put statement, and the put statement later is, so job statement equals identifier and then the step. So we pull those pieces of data out. Which file are we talking about? They may or may not use the keyword file. Some did, some did not. I discovered this later. An open file list, because they may open several, n, where n is any number they chose. So and round, and a continuation statement, which we see there, that says, okay, this continues on the next. And the continuation statement can be used in the middle of complex ifs, complex conditionals, or in put statements, or in open statements, or wherever they felt like doing it. So, and so on it went. The for statement, because there are several varieties of it. The put statement.
I think this is very
Clauses.
valuable to see how the system looks in practice. So, I mean, what kind of work there is behind writing a transpiler. So I think that is nice.
Yeah. And then, of course, this is the fun load translate program that we ran. And this is the other end of it. I used Terence Parr's string. What did he call it? String template?
Yeah, I would say string template.
I think it's string template. The writer of Antler, basically. Yeah. There we see the header at the top. And the fun load header, FL. So source file generated on job header. Oh, by the way, if this is true, then output them, because sometimes it was not. And then what is the output file? Terence Parr says that if your template doesn't look like a grammar, you're doing it wrong.
We will trust Terence.
Well, yeah. For something where I know the output is, I'm always going to be creating these SQL files, or I'm always going to be creating this scripting language, then I like string template. Once I figured out how to use it, it is marvelously flexible and powerful, and it works well. Terence Parr uses it to generate the parsers out of Antler, therefore demonstrably it works. And once I was able to figure it out, it works well for me. If I'm writing something a bit more flexible in terms of what it outputs, string template's not good for that. It knows how to do a thing, and it's very good for that. So for the generation of the SQL code, for shredding XML messages, and the XML messages look kind of like this. What's the action? this is the information, the data, this is the record key, and so on. And they all look the same, except this block in the middle is the different columns for that particular, or fields for that particular table. So the SQL to rip this apart and persist and so on is used. Uses the metadata that, in fact, the transpiler used. But we also have to generate the C# code that knows how to shred this XML message. In the end, we also generate one set of the Java code that gets merged into the rest of the project, because it is very much to do with what are the columns in this particular table and so on. So because we were generating SQL and C# and Java, and as it turns out, fun-load code as well that wound up generated, we went with a Python program and using a templating language called PyroTemp, partly because I was the only person in the group who knew string templates, and I was able to push some of the writing of the PyroTemp templates off to spread it around the team. So if producing just one type of output, string template is extraordinarily good for that, and fast. Even if it is using answer 3, apparently. But if from the same set of metadata you have the requirement to build different things in possibly different languages, then we went with a Python environment and PyroTemp templates. PyroTemp because it was relatively simple, straightforward. There are hundreds of templating capabilities out there. So it was just a question of choosing which one to work with.
I think that has been very instructive, and I would like to be sure that we have time to ask you also more about you, and in particular, can you tell us what kind of services you offer in your role as a consultant?
I've said we and I've said the team a couple of times. DataView is a loose collaboration between currently 4 of us. Alfredo Ariza actually owns DataView. Brendan, Bill, and myself, we actually have our own one-man band consulting companies. So, but Brendan and Alfredo have been working together for quite a number of years. Even when they were full-time employees, they worked together. Brendan and I ran into one another at a consulting environment, in a consulting engagement, and then introduced me to Alfredo when they landed this modernization exercise, for which we also pulled in Bill Fellows. Apparently he's no longer a Microsoft MVP because COVID got in the way, and therefore he wasn't doing the SQL Saturday. It was tougher to do community-based things when you couldn't get a community together so easily. But he's also co-author of a thing called the BIML book, which is Business Intelligence Markup Language, which is an XML grammar, which you use for generating Microsoft SSIS packages, among other things. In fact, it's a full-scale scripting language, and therefore you can generate. XML is just text, and therefore all code is just text, and therefore you can generate pretty much anything. The word data is in the name because data services, data migrations, data visualizations, data cleansing. As it turns out, even wound up involving cloud migration. So currently there's another client we're working with who have wanted to go to the cloud for some time, largely because they've got almost no IT people, but they have a bunch of servers and VMs and so on, and they need to get out of the business of having it online. So move their databases at least to start with, then take some of their old code, some of which is in VB.NET, and again, it's a decade old at this point. Reworking those. They're an event-driven business that operate in a batch mentality because, hey, that's what was known. So we are helping migrate their data to. We work largely in the Microsoft world, although three of us, these three, we also have Oracle and so on experience. In terms of cloud work, most of it has been in Azure because it was there and it played in the environment. So we're moving the data, or have moved databases there, taken some of the older application, and as businesses change, turn them into functions that react in terms of events happening, service bus, queuing messages, because all of us and I were fond of the concept of queues because the infrastructure preserves the data till you can get to it. And in terms of what we're talking about, in terms of data, when we can get to it, in terms of messaging from the system that we're working with, on average, they're coming in every millisecond. And it's an average, and therefore there are outliers. So some are more than others. So we do queuing because the underlying environment will help it. So you've got fast-paced, near real-time stuff, and you need to move data. This is what we do. This is something we built in R because it knew how to do small multiples. And these are the active queues during a particular 5 minutes. The red line is the 3-second mark. And so built into the code we generate is store when we finished dequeuing, when we finished persisting. And then we can take this and then turn that into information as to what exactly is happening. The denser the line is, the more observations. So their quoting system is one of the busiest. And while there are peaks at one particular millisecond that came close to the 3-second, most of the time we're well within that. And we needed these kinds of, so we turn data into information that can be used, one, for the business, or two, to show the business just how good we are, look what we did, and to in fact help diagnose what problems might actually occur. So those are the services. It's data centric, but it's about migration. It's about turning data into information in some way. And that's what we do. And me, I write code that writes code. Because there's too much code, as you well know, there's too much code to write. And there's only 4 of us. We borrow other people as needed, but for some things, there's just too much code to write. If you can make it a pattern, I can make it automated.
I think these give a very good idea of what you're doing at DataView. And I would like to thank you for sharing all of your experience and explaining how you did concretely this project. And I think for me, it's been very interesting. And so thank you, Kevin, for your time.
Okay, I am very very happy to have this opportunity because it's a practical example of what many people think about. These things are doable. They're not easy, but they are doable. If I could only figure out domain-specific languages for some of this, I'd be even happier, but I have a lot of work to do in that area before I get anyway useful.
Let's think about that for the future. Thank you and goodbye.
Okay, thank you. Thank you for your time.